Okay. So, hello everyone. In today's session, we will be doing the Docker in a day workshop. Okay. In this, we'll be having a lots and lots of hands-on as you all are looking forward to. And we'll have a theoretical explanation as well of what actually Docker is. Okay. So by the end of this course, you'll have a deep understanding of all the main concepts and a great big picture overview of how Docker is used in whole software development process. The session is a mix of animated theoretical explanation, but also lots of hands-on demos for you all to follow along. You will get your first hands-on experience and confidence to use Docker in your projects, as you all said in the chats that most of them are beginners over here. So with this session, you will be able to at least start with the hands-on on your project as well on Docker. So we will start with the very basic concept of what Docker actually is and what problem it solves. Okay. In the later stage, we'll be talking about the difference between virtual machines and Docker. We'll go through the Docker installation on Mac. I have provided the instructions in the chat as well. So if you haven't done the installation yet, please do it. And if you have any other systems, you can simply go to the Docker docs and have the installation done. We have all the detailed steps over there. After that, we'll be looking at the very basic Docker commands. Okay. And after that, we'll be creating our own image, pushing it to the Docker registry, and then we'll be looking at the Docker Compose, and we'll see how we can containerize our own application. Okay. Don't worry at all. Be rest assured that whatever terms you're listening, it'll be very overwhelming at the beginning. But then by the end of the session, you will be a lot clear on all these concepts. Okay. Just give me a minute. I'll quickly share my screen. Let me know once it is up. Ishwarya, I am not monitoring the chat, okay? So if there is anything on chat, you just keep a track of it and then we'll discuss that, okay?
Sure.
I'll quickly share my screen. Let me know once it is up. Is it up?
Yes, it is.
Okay. Okay. So let's begin with the Docker workshop. Please mute your mics. If you are not speaking, turn on your cameras if possible. Let's have an interactive session all together. And you can also raise your hands if you want to talk during the session. Okay. And one thing that is not mentioned over here is you can keep putting questions on chats, or if you have any doubts, you can keep putting it on chats and we will be pleased to answer all of those. So as I said earlier, that what we'll be covering in this session is we'll be seeing why use Docker, what is Docker, Docker architecture, installation, basic commands, what are Docker volumes, images, and what is Docker Compose, and the Docker network. Okay, last we'll be covering the Docker network. We'll have a Q&A session for solving your doubts and queries. Okay. So before learning anything, the very first thing that comes to my mind is that why use Docker, right? So can anyone tell me why use Docker? You can simply unmute yourselves and tell me. Why use Docker?
There can be few process which for example Elasticsearch, which should be running on your system for other things to be tested, so which is easy with Docker because you can create those images and have everything in a environment to run, creating an environment.
Okay. Thanks, Dipti. Yes, Sanil Kumar.
Solves the dependencies problem.
Okay, yes. Keep going the answers. Anyone else wants to give it a try?
Hi, this is Neha. So yeah, I previously, they used to be like when we have to move code to various environments, it used to be little difficult. With Docker, everything comes in a package and you don't face any environmental issues there.
Correct. That's true. Thanks, Neha. So let's see, why did I start working with Docker? Why did I come across Docker and I learned Docker and Kubernetes and all these stuff, So let's go. So we're going to start by looking at the high level overview on why you need Docker and what it can do for you. Okay. Let me start by sharing how I got introduced to Docker in one of my previous projects. I had this requirement to get up an end-to-end application stack, including various different technologies like a web server, Node.js. Uh, who is on? I think Manika, can you just go on mute? Okay, better. Thank you. So yeah, so I had this requirement to set up an end-to-end application stack, okay, which included like various different technologies, a web server using Node.js, a database such as MongoDB, a messaging system like Redis, and whatever orchestration tool I wanted to support, okay. So we had a lot of issues developing this application stack with all these different components, okay. First of all, their compatibility with the underlying OS was an issue. We had to ensure that all these different services were compatible with the version of the OS we were planning to use. Okay, that's the first thing. Then there have been times when certain versions of these services were not compatible with the OS. We have had to go back, like we had. So then again, we had to go back and look at different OS that was compatible with all of these different services. Okay. Secondly, we had to check the compatibility between these services and the libraries and dependencies on the OS. We've had issues where one service requires one version of a dependent library, whereas another service required another version of the dependent library. A lot of chaos, right? So as you can see, different Node.js, like the Node.js, the MongoDB, Redis, Ansible, all of these are using different libraries, dependencies, and the OS and the OSs, right? So they have to be compatible with each other and the libraries, dependencies, and the OS as well. Correct? So the architecture of our application changed over time. We've had to upgrade to newer version of this component or change the database, etc. And every time, every single time something changed, we had to go through the same whole process of checking compatibility between these various services, components, the underlying infrastructure. So this compatibility matrix is usually referred to as like a matrix of health. Okay. We were like literally not understanding, okay, what to do now, because there are so many repetitive things going on, right? So we call it the matrix of health. Okay. Just a minute. Yeah. So and also this is one thing, the compatibility of the services with the underlying OS and the libraries and the dependencies, that is the one thing. The other thing is every time we had a new person in our team onboarded, we found it really difficult to set up a new environment. The new developers had to follow a large set of instructions, run hundreds of commands to finally set up their environment. We had to make sure they were using right operating system, the right version of each of these components. And there were also times when one developer was comfortable with one type of OS and the other developer was comfortable with another type of OS. So then again, that is also a concern, right? Okay, now how do we make that issue resolved? So all of this made our life in developing, building, and shipping the application really, really difficult. I needed something that could help us with the compatibility issue and something that will allow us to modify or change these components without affecting other components and even modify the underlying operating system as required. Okay. So every time you must have come across this, right? It works on my computer, but we cannot ship your computer to the client, right? Then you must have come across like, okay, it works on my machine, but it's not working on others' machine. So let's ship your machine. That is how Docker was born. Okay. So let's start with overview of Docker. All right. So what is Docker? Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your application from your infrastructure so you can deliver software very quickly. With Docker, you can manage your infrastructure in the same ways you manage your applications. By taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between writing code and running it in production. Docker provides the ability to package and run an application in a loosely isolated environment called a container. The isolation and security allows you to run many containers simultaneously on a given host. Right. So you can see, right, when I said all these statements about what is Docker, you can understand whatever the issues we were facing in the matrix of health that we had, they're getting resolved here one by one. You can see the isolation part, the compatibility of the OS part, delivering the software quickly part, right? It's very isolated. It's loosely isolated from the environment that it is on, actually. Okay. Coming to what is containers now. A container is a standard unit of software that packages up code and all its dependencies. So the application runs quickly and reliably from one computing environment to another. A Docker container image is a lightweight, standalone executable package of software that includes everything needed to run your application: code, runtime, system tools, system libraries, and settings. Whatever application I'm building, whatever dependency it requires, whatever libraries it requires, and whatever the software requirements it requires, all of this is packaged in a single image, and then that image is shipped. And that is why we say that it's very easy to ship the image, right? We can do it quickly and very reliably as well. Container images becomes the containers at runtime. So what we do is we ship container images and not the containers. These images will become containers when we run them. Okay, we'll see that further, how we can run that image and how a container is formed. Okay. Available for both Linux and Windows-based application, containerized software will always run the same regardless of the infrastructure. Okay, that is the main point, right? Whatever the infrastructure is, my application should be running. There should be not a case wherein someone will come and tell me, okay, it must be running in your machine, but it's not running in my machine, right? We cannot get those type of complaints from the client or be it in the team as well. So that is why Docker comes into picture. Containers isolate software from its environment and ensure that it works uniformly despite differences, for instance, between developing, staging, production, whatever environment it is. No matter what, your app should be working. That is what the containers will ensure. So, where do containers live? Even before where do containers live, let's talk, like, if you have any questions until now, like, are you clear with what is Docker? Why do we need Docker actually? What was the problem statement? And then I came across Docker and then we resolved those issues with Docker. What are containers? Do you have any issues until now? Do you have any questions until now? Then you can let me know. Let's take a minute pause. Okay. I think silence as a no. Further questions? Okay. So let's.
There is a question, Kinnari, from Vishnu Das, how to create containers.
Yes. So this is like, I'm just telling the theoretical part to you. And in the further part, when we go to the hands-on part, you'll be actually creating the containers, stopping them, starting them, maintaining them, killing them. All of these will come in the further session as we proceed. Okay. Apart from that, if you have any questions on the theory part, you can feel free to ask me. Until now, we're just covering the theory. I'm trying to set a base of what is Docker, what is containers, why do we needed them in the first place. Okay. After that, we'll go to the hands-on part. When you come to the hands-on part, you'll understand how do we create containers. Okay. Anything else? Okay. If not, let's go to where do containers live. So containers live in the special type of storage repositories. They can be private repository, they can be public repository as well. A private Docker registry allows you to share your custom-based images within your organization, keeping a consistent, private, and centralized source of truth for building the blocks of your architecture. Okay, whatever images you're creating, you can put it in a private repository, and the organization-wide you can share those images. Coming to public repository, a public repository is accessible by anyone running Docker, and image names include the whatever images, like there are images that we push, correct? So the image name is like organization or the username. So for example, if it's my image, if I'm pushing my email, like creating an image and pushing it to my Docker Hub account, so I should have my username, that is Kinnari Sutaria / the repository name. For example, it's a Hello World app. So it'll be Kinnari Sutaria / Hello World app. Okay, that is how we put it in the hub. For example, let's go to the hub link first. It's loading. Okay. So as you can see, this is my Docker Hub account, right? So in my Docker Hub account, you can see these images: compose demo, test infra, assignment, and whatever, right? These are the experiments which I was doing. So I pushed these images. Now these images are all publicly available. Can you see here? Public. And these are the number of pulls people have took. So for this particular image, test infra, 9 people have took a pull out of it. For this infra assignment, 4 people have took a pull out of it, right? For this, 3 people. For this, 8 people. So as you can see, so when I go inside this compose demo, let's have a public view. That's for my use. That is push. But when you see the public view, you can see over here, right? The name of the image is Kinnari Sutaria / compose demo. Okay. It was pushed 12 hours. It was updated 12 hours ago. If you want to pull, you can just see Docker pull, copy this command. And when you put it on your end terminal, you will have my image on your machine as well. Okay. We'll see that also how we can do it. I'm just showing it right now. So for example, yeah, someone unmuted themselves.
Yes, Kinnari Sahiti has a raised hand.
Yeah, tell me, Saiti.
Like, what does image exactly mean here? What is image? What are you addressing as?
See, image as we spoke over here, right? Images like container images are like a lightweight standalone executable package. Okay. It'll have everything. It'll have your application, it'll have the libraries, it'll have the dependencies, whatsoever is required to run your particular app, it'll have everything in that. Okay. So we'll see further how we create an image, what is an image in detail. But here until now, I'm just trying to show the overview of what these terminologies mean, and we'll be working upon that further. I just wanted to show what Docker Hub is. It looks like this. This is the public repository. Okay. So public repository looks like this. So this is for my case. I have pushed this number of images here. Okay. But I want to see the thousands and tons of images that are available online. So when you can see, Vidya Lakshmi, do you have any questions?
Raise your hand.
Aishwarya, can you mute whoever is unmute right now? Yeah. So, yes, coming back over here, we have Nginx, we have BusyBox, we have Ubuntu. So, for example, if you go to Ubuntu, just open it. What you have to do is docker pull Ubuntu. You'll have Ubuntu on your machine. As easier as that. Can it get any more easier? I don't think so. So, for example, if I want Ubuntu, I want to run Ubuntu, I'll just come here, I'll do docker pull Ubuntu, and I'll have Ubuntu on my container running on my machine. Okay. It cannot run like this. We have to run the run command as well. But yeah, it's as simple as that. And like it's like in number of seconds, you can have whatever container you want on your running on your machine. Right? It's as easy as that. Having Node, Redis, all of this. You can have any of them. So this is what Docker Hub is. It's a public repository where everyone pushes their own images. Okay. Going back.
Kinnari, just one question on chat by Sneha. Can we say image is a snapshot of a container similar to AMI of AWS?
AMI of AWS is like you will have the okay. It's basically virtual machines, right? Whenever we create we have virtual machines, right? On VMs, we have virtual machines on the like EC2 instances and all, right? So AMIs basically will have the OS as well. Docker images don't have the OS inside them. They'll use the OS which is there in your machine. Okay. For example, if mine is a Mac machine, it'll use my Mac's OS. If yours is a Windows machine, it'll use your Windows OS. Okay, we'll come further. There is a question, there's a further slide wherein we'll discuss what is the difference between a virtual machine and the Docker, right? Containers. Okay, going forward. I think someone is unmute. I'm getting background noise. Ishwarya, you can just go ahead and mute whoever is unmute, okay? They must have done it by mistakenly or, yeah, whatever.
Yeah,
Okay.
sure.
Thank you. Okay, going forward. See, here we are in the next slide. Difference between Docker and virtual machines. Okay. So, okay. Like by seeing in this slide, can someone tell me, what do you think? What will be the difference? Do you think Docker and the hypervisor or virtual machines are the same or are they different? What do you folks think? Just put it on chat. If you think they are same, yes. If they're not same, no. My question is, do you think Docker and the virtual machines are same? Yes or no? Please go ahead and put your answers on the chat.
So here,
So many news.
Here operating system is like decoupled from the applications in Docker, but in virtual machine, it comes with the operating system.
Okay, great. What else? Anyone wants to give it a try? Okay, let's see. So yes, you all are right. Whatever you said is that they both are different. I had answered it earlier, but yeah, still they both are different. The answer is like no, because unlike hypervisor or virtual machines, Docker is not meant to virtualize and run different operating systems and kernels on the same hardware. Okay, this is a very big difference. The main purpose of Docker is to package and containerize applications and to ship them and to run them anywhere, anytime, as many times as you want. So that brings us to the difference between virtual machine and containers. Okay. Uh, yeah. So in case of Docker, we have the underlying hardware infrastructure and then the OS and then the Docker installed on the OS. Can you see the structure on the slide? You can see that the OS is not part of the Docker. Okay. Then the Docker then manages the container that run with the libraries and dependencies along. And in the case of virtual machines, we have the hypervisor like EXS on the hardware and then the virtual machines on them. As you can see, each virtual machine has its own OS inside it. As someone had rightly said in the chat, right? That virtual machines have their own OS. Docker don't have their own OS. Docker uses the OS that is the underlying OS. Okay. Now, the dependencies and the application, the overhead causes in the virtual machines, the overhead causes a higher utilization of underlying resources. As there are multiple virtual operating systems and kernel running, the virtual machine also consumes higher space as each VM is heavy and is usually in gigabytes in size. Whereas Docker containers are very lightweight because they don't have their own kernels or they don't have their own OS, right? They'll use the underlying OS. That's why their size is usually in megabytes. Okay. So this is the very first difference, that is the size. The VMs have a very huge size, that is in gigabytes, and the Docker containers have a very light size, that is in megabytes. Now, this allows Docker containers to boot up faster, usually in a matter of seconds, whereas VMs, we know, takes minutes to boot up as it needs to boot up the entire operating system. We all have come across this, right? While we are working on various projects. At least myself, I have really experienced this. Earlier, I used to spin up some VMs or spin up EC2 instances. When you spin up EC2 instances on cloud and all, it's very like, it has reduced the amount of time in spinning up the OS to very less, but still it takes up a couple of minutes, right? But with Docker containers, it's not like that. It's not like that because it uses the underlying OS and does not have its own OS, right? So that is the another difference. It really takes very less time to boot up the Docker containers. It is also important to note that Docker has less isolation as more resources are shared between the containers like the kernels, but the VMs have complete isolation from each other since VMs do not rely on the underlying OS or the kernel, right? You can run different types of applications built on different OSs such as Linux based on or Windows based apps on the same hypervisor. Okay. But so like, see, so that is why these both are different. Now, having said that, it's not either a container or a virtual machine situation. It's not like either or, okay? You can use either container or virtual machine. It's containers and virtual machines. So this is a little bit of more extra input of mine of how the containers and the virtual machines can work together and how it will make a good impact on your project for the everything, quick, making it quick, okay? The scaling up, scaling down, everything, okay? Now, having said that, it's not either container or virtual machine situation, it's containers and virtual machines. Now, when you have large environments with thousands of application containers running on thousands of Docker hosts, you will often see containers provisioned on virtual Docker hosts, okay? That is when they both come together. That way, we can utilize the advantages of both technologies. We can use the benefits of virtualization to easily provision or decommission Docker host as required. At the same time, make use of benefits of Docker to easily provision applications and quickly scale them as required. Okay. But remember that in case we will not be provisioning that many virtual machines as we used to before, because earlier we provisioned a virtual machine for each application. So what this Docker does is, instead of having one application run on one VM, we can run multiple applications on a single VM itself. So this is how it is helping us, right? Okay, I can see a lot of chats. Okay. Anything else? Anything on the chat which I have to answer? I can see a lot of chats going on. Anusha?
No, Kinnari, we are looking into it.
Okay.
There are no questions.
Okay. So, are we clear? difference between Docker and the virtual machines? If yes, I'll go forward. Okay.
Generally, we have one container for one. For example, Node.js will have a separate Docker. If you want to have a Spring Boot, we'll have a separate Docker. Do we go like that, or can we have everything in the same container?
We'll be having different containers running on the same Docker host. For example, say my Mac is a Docker host. Okay. My machine is a Docker host. And my application is using Redis, my application is using Node, my application is using MongoDB, all these three. Okay. Suppose it's using these three things. What I'll do is I'll spin up these three containers. I'll show you how we can do it in one go itself. We'll create a Docker file. In Docker file, we'll mention all the requirements and what ports should be opened, what should be the environment variables, what should be the command executed when these containers are up. All these things we'll see forward. But what happens is I can run all these three containers in my host. Okay.
Can we have all the three in same container? No.
It won't make sense, right? So then what is the point of having it in there will be no isolation. There will be again dependency, right? If I had everything in the same thing, same year, I have to see again, okay, if this is compatible with this or not. If it requires this dependency, this container, this service requires other dependency, right? So then again, it will be like
how will be the network latency? For example, if you are running different containers, we install, for example, Spring Boot has a API, and then Node.js has a front-end UI. So we have to create a network call between these two. Like we'll have a, I'm not sure how Docker works. We have to have a network call. The port I called out. This will speak to one port, and this will speak to one port. That will be kind of a network call. For example, it is in the same Docker host, then okay, it is fine. If you are going to put in a different Docker host, then the network latency will be there. No, like.
Yeah, see, it depends upon your use case, right? For example, if I am running an application, I'll use the same Docker host. For example, if I have a node app to be deployed, I'll use the same Docker host for all these services that I want to be up and running. And when I use the same Docker host, I'll come to the networking part as well. There are three different types of networks that we use in Docker. One is bridge, one is host, and one is none. Okay, it will be a completely isolated environment. We'll come to there over in the later stage, but using different hosts or using the same host, it depends upon the use case that we have, right? So yeah, right now it's not what we are covering over here right now. We'll come to the Docker network part and we can talk more about it. But majorly, to answer your question, it will depend upon what use case you have. Okay. So ideally, yes, if it is in different host, it will take a little more. The latency will be more, but if it's in the same Docker host, the latency will be less. But the difference will not be very much, you know, it'll be a little less difference. It'll be quick, basically. If nothing further, we can go forward.
No questions in chat, Kinnari.
Okay, thanks, Anusha. So going forward. Okay, coming to the architecture of Docker now. Now, as you all said, you all must be wondering, okay, how is the image coming? How is the container getting spinned up? What is happening in the backend when I put a command Docker pull a certain image, say Nginx, Node, or Ubuntu? What happens? Okay. So let's talk about that. So can you see this diagram? Okay. You can see we have a Docker client, we have a Docker host. In the Docker host, we have the Docker daemon. Then we have the registry. Registry we saw, right? We saw the registry wherein we saw the different images there. There were customized images that were pushed by me. There were actual images sent by other people as well, like Nginx, Node, Redis, and whatnot, right? That was the registry part. Talking about the client is, we are running different commands, right? So that is why we're using the client, Docker client, to put those commands. This Docker client will communicate with the Docker host, which has the Docker daemon. The Docker daemon will do the management of the containers, images, and whatever commands it's getting from the client, and fetching those images from the registry, and all these things are done by the Docker client. So Docker uses a client server architecture. Okay. The Docker client talks to the Docker daemon, which does the heavy lifting of building, running, and distributing your Docker containers. Okay. All the heavy lifting part is done by the daemon. The Docker client and daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon. Okay. The Docker client and daemon communicate using a REST API over Unix sockets or a network interface. Another Docker client is Docker Compose that lets you work with applications consisting of a set of containers. So we'll come to the Docker Compose in the later stage. So what Docker Compose will do is whenever you have an application where you want to spin up a lots of number of containers, like say 3-4 containers altogether, then that really helps you in doing so. Docker Compose. So here you can see when I'll shoot a command Docker build, Docker pull, or Docker run of certain image. Say for example, I'm doing Docker pull for Nginx. Okay. So what happens is this REST API call is going to the Docker host. In the Docker host, we have the Docker daemon. This Docker daemon will first check if I have the Nginx image over here or not. Okay, it'll check if it has the Nginx image locally or not. If it doesn't have, it does a call to the registry. Then this registry will check if it has an Nginx image. Yes, it does have. So then it will go back, it'll send the Nginx image over here. And then when we run the Docker run command, it will use the Nginx image to run the container. Okay. So all this management is done by the Docker daemon. It is a very simple architecture of the form of client and server. And this is how the working happens. First, whatever command you shoot for pull or run, it'll go and check if it has the image locally, it'll pull that image and create a container. If it doesn't have it locally, it'll go to the registry, check for that image, bring that image to your local and then run the container. Okay. Going forward, let's talk about the components of Docker. So first is the Docker daemon. The Docker daemon listens for Docker API request and manages Docker objects such as images, containers, networks, and volumes. A daemon can also communicate with other daemons to manage Docker services. Okay. In today's session, we'll be seeing how images are created, how containers are created, how networks are created, and what are volumes. Okay. Then going to the Docker client. The Docker client is the primary way that many Docker users interact with Docker. When you use a command such as Docker run, the client sends these commands to Docker. That is the Docker daemon, which carries them out. The Docker command uses the Docker API. The Docker client can communicate with more than one daemon. Okay. Components of Docker continued. We have Docker desktop. We have Docker registries. Earlier, we all used to use Docker desktop because it was a open source free community version Docker desktop. Okay, but now that they have licensed it, we have different we can use like Rancher desktop for managing our Docker containers and everything. Or we can use the Colima that we saw. We have sent it in the chat as well for the installation, right? We can use Colima as well. So yes, that is how we use it. We use that for like easy management of all the containers and everything. We can do start, stop all using the Colima or the Docker desktop. Next is Docker registries. We talked about Docker registries earlier, right? Docker registries stores the Docker images. Docker Hub is a public repository that anyone can use. Docker is configured to look for images on Docker Hub by default. So whatever images you're pulling or trying to run, what Docker will do is it will by default check in the Docker Hub. You can even run your own private registry. When you use Docker to pull or Docker run commands, the required images are pulled from your configured registry. Okay. When you use a Docker push command, your images are pushed to your configured registry. So two things are done on the registry. One is the pull, one is the push. It can be done in the public repository registry as well and in the private registry as well. So if you have to use a private registry, you'll have to configure it. You'll have to create a registry first, right? We have options for creating registry on AWS and many other options as well. So that is how we can use Docker registries. Now coming to Docker objects, the very first, like when you use Docker, you're creating using images, containers, networks, volumes, plugins, and other objects. So this section will brief you on what are these objects. Okay. So as someone had earlier asked, right, what is an image? So let's see what is an image actually. An image is a read-only template with instructions for creating Docker container. Okay. Often an image is based on another image with some additional customization. For example, you may build an image which is based on the Ubuntu image, but installs the Apache web server and your application, as well as the configuration details needed to make your application run. So what happens over here is in the images, it'll use something as a base. So say, for example, I can use Ubuntu as a base, right? Because it's already available, readily available. I don't have to do anything for it. I just have to do a Docker pull, get the Ubuntu image, and I'll get it ready. Now I want to install Apache web server on it, and I want to install my application as well. Okay. So once that installation is done, what I'll do is I'll again create an image out of it. So now my customized image is ready, where it will have the base image as Ubuntu and all the two applications running. That is Apache web server will be running on it and my application will be running on it. So now this is a customized image having all these three, right? So how it was made? First, the Ubuntu image was there. On top of that, I installed Apache. On top of that, I installed my application. And then that whole customized bundle is pushed on whatever registry you want. So for example, if my colleague wants to use that, now he won't have to again install the Apache, install my application. No, he'll simply have to pull the image that I have pushed by creating my customized image using all these three, right? I hope that answered your question. Whoever had asked that question in the chat that, okay, what is the image? You might create your own images or you might only use those created by others and published in a registry. To build your own image, you create a Docker file with simple syntax for defining the steps needed to create the image and run it. Okay, whatever commands that we said over here, right? We have Ubuntu base image. So we'll write from Ubuntu. Okay, then we have certain instructions. Say I want to install Apache web server. Say I want to install Node.js. Say I want to install Redis. So for that, we have different steps that we write in the Docker file. Okay, and it's as simple as that. Once that image is created, you run it. Now, each instruction in a Docker file creates a layer in the image, as I said right now, right? When you change the Docker file and rebuild the image, only those layers which have changed are rebuilt. See, this is a very important point to emphasize on. As it says that only those layers which have changed are rebuilt. Say, for example, in my Docker file, I had the Ubuntu image, then I installed Apache, then I had Node. So now, for example, I was using Node version certain, say 4.0, okay? And now I'm using a different Node version. So when you rebuild the image, it won't install Apache again because Apache is already there, right? So it won't touch that layer. First layer was Ubuntu, second layer was Apache, and the third layer was Node. So it'll check, okay, Ubuntu, nothing has changed. Apache, nothing has changed. Third layer is the installation of my application, which was using Node, and the Node version was changed. So it'll just rebuild that part, okay? So that is why this is the part of what makes image so lightweight, small and fast when compared to other virtualization technologies, right? Because it is rebuilding only the part that is changed. Now coming to containers. A container is a runnable instance of an image, okay? In very layman terms, if we say, when we run the image, that is what is container. We can create, start, stop, move or delete a container using the Docker API and client, okay? Or CLI, sorry. So you can connect a Docker API as in when you use Docker Desktop, we used to get an application open up. There were a list of containers that were running on my machine. I could stop them, I could start them, I could pause them. All those options were there itself. So that is how we can use it using the Docker API. And if in the CLI I want, I just have certain commands. Docker start container name or container ID, Docker stop container name, container ID, like that. Okay. You can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. Okay. So you can connect one or more networks to the container. We'll see in the networking part, how we connect to a network and how we disconnect with the network and how we can even reconnect it to the network. Okay. It is that flexible. You can connect and reconnect the network as well. So you can imagine how flexible the Docker is, right? Attach storage to it. So say, for example, when I'm creating a container, I'm doing certain operations on it. As soon as I stop the container and when I again start it, it won't have those changes. So in order for my changes to sustain, what I want is I'll attach a storage to it. When I attach a storage, it will mount certain directory of my machine Docker host to the actual container that is running. So when I spin up the container again, attach the volume, I'll have all the data that I wanted it to persist, right? We'll talk about that in further slides. Also, we'll do hands-on as well by attaching a volume, detaching a volume, and see how the data is being modified, right? A container is defined by its image as well as the configuration options you provide to it when you create or start it. When a container is removed, any changes to its state that are not stored in persistent storage disappear. As I said earlier, right? Whenever a container is removed, all the changes to its state that are stored in persistent storage, only those will be there. Others will disappear. If you don't have a volume attached to your container, whatever changes you're making, it will disappear. Okay. So-
Hi, Kinnari. There is a question in the chat from Anu. I have a Docker file to create a Docker image. Let's say it's running on Linux. If I need to change to different OS such as Windows, should we change the Docker file command? If not, how does it solve the compatibility issue?
Yes, Anu. So for this, you will be using the base OS as Windows OS. Okay, you cannot run a Linux container on the Windows. You can run it when you are using a virtual machine on the Windows. Okay, so basically, what it does is in the goofy format, what the Windows system will do is it will have the VM running for Linux, and that Linux VM will be running the Linux container. But it cannot be the vice versa. You cannot directly run the Linux container on Windows. You'll have a inbuilt, like internally it'll be using the Linux VM and then your machine will be running the Linux container. Okay.
Because for a .NET, right, we usually use all the things are in Windows, right? For a .NET application, yeah, Windows operating system. So how does this Docker works? Because as far as I have seen,
That time you can use the Windows OS as a base image, no? That time you use the Windows OS as a base image. So see, it is like whatever the OS kernel is required for your application to run, that should be there in the system. Okay. So I can run a Linux container on my Windows machine if I have the Linux virtual machine. Okay. So that way, what will happen is I'm running it on my Windows machine, but my Windows machine is actually using the Linux VM and running the Docker on it. Correct?
To answer this question, for example, if you want to run the .NET application in the, for example, in the Sun Solaris or whatever, first I need to install a virtual machine, install the Windows OS on the virtual machine. On top of that, I have to install Docker, and I should run the container image, what are the applications installed.
Yes, exactly.
So in that case, we need the virtual machine.
Yes.
For example, if you want to switch to OS, then we need the virtual machine.
Yes.
To install the OS. Okay.
Exactly. So this I already talked about how is the image made. It's made up of different layers. So yes, let's go forward. Okay. So coming to the demo time, this is something which you all been waiting for, correct? So let's do a hands-on. Okay. I'll just stop sharing for some quick 3 to 5 minutes. I'll send a command. 1 minute. Open your terminals. I hope you have the Docker installation ready. Okay. Just give me a minute.
Kinnari, can you please share that file for setup? I think I joined it late.
Sure. Are you running Docker on Mac?
I don't know. I was having Colima, but how to check whether I am having or not in my Mac?
Just
How to check?
Colima version.
Colima. Okay.
Colima version.
Nothing is coming.
Ishwara, can you put it on chat again, please? The instructions I had given for installing Docker on Mac. Ishwarya, are you there? Okay. She has put the setup steps again. Okay. Install Docker Compose and Colima, and you can check the versions as well. When you check the version, you'll get if it's installed or not. Okay. Okay.
Do we need to install this brew, install Docker?
Sorry?
Or do we need this brew install Docker?
Yeah, you have to install, like I used brew to install all these things, and it's very simple to install it this way. If you have any other way, you can go ahead and install it anyway. Basically, I want Docker Compose, and Colima in your machine. That's it. That's all.
What is brew? What is this brew?
Brew is used for installing different applications or any libraries or anything that you want on your machine. It's used for Mac. So this is the steps for installing Docker, Colima, and Docker Compose on Mac. Are you using Mac?
I'm using Mac. I installed Docker, but I checked whether Docker Compose is there. It is there. Now
Okay.
I'll check whether Colima is there. So brew install Docker, whether it is required or first command itself is okay.
Yeah, whatever is see, brew is a tool which is used to install all these things. If you have
Okay,
installed it,
okay.
while
I'm new to Mac as well. I'm new to Mac as well. I work
exactly.
on Windows previously. I'm new to Mac
No
as well.
worries, no worries. I understand. I mean, I came to Mac like just 1.5 years back only, so I can understand. So don't worry. Just Brew is a tool that we use for installing Docker. Okay, installing anything basically on Mac. It's a very
The
simple thing. When you hit the command, the installation will start. So I always
the,
prefer using Brew.
the first command itself will do, right, to have this
Brew,
session.
Brew install
Install Docker.
Brew install Docker is the
Install.
command if you are using Mac. Okay.
Okay.
What Brew will do is Brew will install Docker on your machine. Okay. But if you already have it, just verify the version, Docker version, Docker Compose version, and the Colima version. If you get
Okay.
answer for all these three on your command prompt, so you're good to go. You have all this installed. That's it.
Sure.
Okay. Coming back. See, we haven't gone through any of the Docker this thing. Sorry.
No, Kinnari. It
No,
was just.
Okay. So we haven't gone through any of the commands yet, but just I want to show how the layering is done. That is why I'm trying to give two commands to you all. Okay. Just run this first. Docker pull redis 625 bullseye. Can you run this? So in this, when you see Docker pull is the command. Okay. Redis is the image that we want. What is the version that we want is 627 bullseye. Can you shoot it on your terminal now? Once you just shoot it, observe what is going on, what it's downloading. Can you see the downloading happening from the Docker Hub?
Yes.
Okay, awesome. So if it's happening, you saw that, okay, whatever layers were downloading. Now what I want you to do is do the same Docker pull Redis, but now we want the latest version. I put it on chat. You can put it like just copy paste the whole command. So what it is doing earlier, we had 627 bullseye version. Now I want the latest version. When you shoot this command, see that there will be some lines wherein will be written already exist. Did you get that?
Yes.
You got that, right? So when when that happened, it means that the the architecture we saw, right? We saw that if we'll check for the image if it's there or not. If it's there, it won't pull it from the Docker Hub. So what happened is the Redis image was there on our machine, but there were certain layers that were not present. For example, for latest version, there was different layers. They were changing some layers. So what it did was it did not pull the whole, it did not rebuild the whole image that was there for Redis. What it did was it did just change those layers that were different for the latest version, right? That is how the layers happen. Okay, that is what I wanted to showcase, and how there are layers in the image. Okay, I'll share my screen again. Just give me a minute. Yeah. Okay, is it up? Hello?
Yes.
Okay. So we saw that how the layering is happening. Okay. Now coming to Docker namespace. So Docker uses a technology called as namespaces to provide the isolated workspaces called the container. When you run a container, Docker creates a set of namespaces for that container. By default, it's a default namespace itself. But if you actually provide a namespace externally, then you will be using that resource with that namespace. Namespaces are a feature for the Linux kernel that partitions kernel resources, such as that one set of processes sees one set of resources and another set of processes sees a different set of resources. Each aspect of a container runs in a separate namespace and it accesses its limit to that namespace. So for example, if I'm pulling an image, if I'm running a container in the namespace dev, okay? So then this particular container will be, if I do whatever command I'm running for that container, every time I have to provide a namespace dev. If I don't provide the namespace dev in the command, it'll say that I don't see the container running. Why? Because the Docker host is unaware of that particular namespace. It will check in the default namespace, it was not there, right? That particular resource was not there. Say, for example, there's a house, okay? And there are 2 rooms in it, okay? So you will come to know, you can access that particular room when you are inside that room only, right? Inside that particular namespace. That is what I'm trying to explain over here. Okay. So for the isolations, we can create namespaces. Say, for example, we have Q environment, we have dev environment. We want certain service, like we want a different set of all the resources for the dev environment. We have different resources for this Q environment. So then that is where namespaces come into picture. We can have different namespaces and we have to create the resources with that namespace. So it will be very isolated. There won't be a mixed match of those resources. Okay. Coming to Docker installation. As I said, I've put all these things on the chat itself. All these are steps for installation of Docker. I hope you have already installed Docker as it was in the prerequisite itself. Okay. So now coming to the Docker commands. Okay. Now we'll have lots of hands-on going on. But first, let me just walk you through the commands and then we'll do a hands on it. Okay. You can do it along with me, or we'll have 2 minutes after I do it, and then you can do it as well. Okay. So the very first command is run command. Run command is used to start a container. Okay, so for example, if I run docker run nginx, it will start an nginx container. It will check if if there's an image in my machine or not. If it's not, it'll go to the hub, bring the nginx image and start running it. Okay, don't worry, we'll execute this command as well. For now, just let's walk through them first. Okay. Then we have the ps command. What does this ps do? It will list the containers. The docker ps, it will list all the running containers. And if we do docker ps -a, it will do list all the running and the stop containers as well. Okay. Now how to start a container? Docker start container name or container ID. Okay. We can use both of them. You can use either container name or you can use container ID for starting a container. Okay. Stop again. Instead of start, you can just replace it with stop. Docker stop container name or Docker stop container ID. It will stop the container. So now when you stop the container and you want to see it in the list of the containers, you will do docker ps -a. Okay. Now, removing a container. Why do I want to remove container? Because if it is a stop state, I don't want to use it. It is unnecessarily consuming my space, right? So that is why I'll remove the container. What you can do is docker remove container ID or the container name. It will simply remove it. You can also remove multiple containers at the same time. What you have to do is docker rm, put the container IDs separated with a space. All those containers will be deleted, removed. So I'll showcase that as well. Coming to images. When I run the docker images command, all the images that are there will be listed. Okay. How to remove an image? It's similar to docker removing container. Same, but you just have to put docker rmi, that is remove image and the image name. But for this, you have to ensure that whatever containers are using this image should be removed first. Then only you can remove this image. Otherwise, when you run this command, it will give you an error that, okay, you haven't stopped the containers or removed the containers and it's using this image. That is why we cannot remove this image, right? The dependent containers must be first removed, then only the image will be removed.
So container is the instance of the image.
Running instance of the image.
Running instance of the image.
Yes. Image is just an artifact, right? It will have all the things packaged. When I'll run this image, then only it will come in the container version.
So if we want to have a load balancing environment, then I can run, I can have single image and I can run 3 container or 4 container, whatever I want.
Yes, yes. Any number of containers can use the same image. Okay. No worries with that.
The load balancing and all, like we have to install a separate load balancer for this, or how it handles.
Yes,
you have to
yes.
install a separate load.
All
Okay.
separate load balancer. This is all is externally handled. Then coming to the Docker pull an image. Okay.
I have a question. So when you do docker ps, it lists all the process which are running, right? So when you want to see all the process running in particular namespace, can we do that?
Yeah, we'll do -n and we'll provide the namespace, dev, QA, whatever your namespace name is. That's it. All these commands, if you have created a different namespace, everywhere you have to put -n, leave your namespace. That's all you have to do.
Okay.
Okay. So now pull command. So now why do we want pull command? When we run the docker run command, what happens? It will first pull the image from wherever it is, from local or from the Docker hub, and then run it, right? Say for example, I want to just have the image in my machine and run it later. So that is why we have the pull command. It will just docker pull nginx, it will just bring the image, keep it in our machine. That's it. So now comes the demo time. Let's demo all this. Is my terminal visible?
Yes.
And are you able to see the font as well?
Yes.
Okay, great. So, as I said, we'll first do Docker full Nginx. Okay. You can follow along with me, or you can wait for me to execute all these commands and then run it. Okay. Let's see first Docker pull. So what this will do? It'll check using default tag latest. Okay. Default tag is latest. It'll check if it is there. See, it was already existing and certain parts were not there. So it'll go and download those. Okay. So this is the downloading part happening. Yes. So it has downloaded the Nginx latest. Okay. Now what I'll do is I'll see. I downloaded an image, right? So when I do Docker PS, this is a different container running. Okay. This is not the container which is using Nginx here. Okay. Wait, I'll kill this so that you won't be. Stop the container ID. Okay. Now when you do Docker PS, you'll get nothing. Okay. Now let me do Docker images. So as you can see, Docker images, these are the list of images that are there on my machine. Okay. So you can see there's an Nginx image also over here. Okay. So it was downloaded 3 days ago. This is the image ID. This is the tag. So you can see Redis. I had downloaded the latest version. I had downloaded the 627 bullseye version as well, right? So it shows separately over here that this was the tag used. So whenever, for example, I had this other image as well, which has a different tag. So these tags will help us have the versioning part. Say, for example, I push an image which was version 1. Now I do certain changes. My product has more features now. I'll push another image. It will have version 2. So you can use, by this versioning, you can use whatever version you want to use. Okay. That is where these tags help us. Okay. So now we saw the Docker images part. Okay. Let's clear it. Now what I want to do is I want to run the Nginx. I have the image, I'll run the Nginx. So as you see, it did not pull first when I run it. If the image was not present, it would have pulled it first and then ran it. Okay. Now you can see the Nginx is running. Okay. You can see it starts worker processes and then now it's running. Okay.
So
Now,
when this pull happens, it will pull the latest, right?
yes, yes. Now when I do Docker PS in other tab, you can see the Nginx is running. Okay, you can see your Nginx. This is the container ID for it. This is the image that is used. This is it created 27 seconds ago. Its status is running since 25 seconds. This is the ports that it's using, and there are random names that are getting assigned to this. Okay, this is not in our hands. If we explicitly mention a name, okay, we'll take that name. Otherwise, this random names will be assigned to the container. Okay. Now, when I see Docker PS -a, there are these stop containers which were earlier done, right? These were the stop containers. Now, let me just remove first stop containers and then I'll show you how it looks. Docker rm. I can give this. Now I'll show you how we can remove multiple containers. Okay. Either you give the container ID full, copy paste it, or what I can do is I'll just simply put 3 to 4 digits of the container. Now this container ID is 521A881 like that. Okay. I'll just put the starting digits 521 and this one is DD5. So DD5. Okay, that's the daemon. Sorry, I cannot.
For me, it is saying Docker worker processor, but it is not coming to the command prompt.
There won't be a command prompt, right?
No, after running this Nginx command, okay, it started the worker processes and it is still there.
Yeah. So it will be there only. So where did I go? Yeah. So right now you are in that shell itself. Okay. It's running.
Okay. I need to open a separate terminal if I want to run another command.
No. There is a certain version of we'll have different like I'll put a -d to detach it. Right now you're attached to the terminal, right? So you cannot do anything.
Okay.
See, I cannot do anything. I'm putting enter, nothing is happening. What I'll do is I'll just show you once. Docker PS when I'll do over here. Sorry. You can see Nginx is running. It's up since 2 minutes, right? Now I'll do.
So try out. So try out any commands. I need to open one more terminal.
Yeah. I'm just trying to show what is happening. That is why I tried out another terminal. But otherwise, I want to use it like this. I'll show you a simpler version, but just 1 minute before that. Now, when you see, right now when I did Docker PS, this was running, right? But now when I do Docker PS, sorry, controlling. Now I do Docker PS, nothing is running. But when I do Docker PS -a, I'll get the Nginx container that stopped right now. See, exited 27 seconds ago. This is what I was trying to show. Now, for example,
how did you stop this? Sorry.
I just Control C. Your terminal was running, right? On the terminal, you had that worker process part, right? You just do a Control C, you'll exit the container. Okay. And when you see the Docker PS, nothing will be there. When you do Docker PS -a, you'll see that container. Now, just this was in the other part, but I'll still show it to you over here itself. When I do a -d, okay, I'm going to put a -d, and now I run Nginx. What -d does is it will detach my terminal. As you can see, now I have the prompt here. Now I can check the running containers here itself. Docker PS. You saw? I can see the running container here itself. -d is detached. If I don't put a -d, it will be attached itself. Now, if I run Docker attach, so now your terminal is attached. Can you see? You're getting? So you can attach and detach as well. Okay. Now it is exited, right? Now, if I do Docker PS again, I don't have any containers running. Correct? Is that clear?
How did you create a container there?
Sorry?
How did you create the containers?
I did a Docker run, right? The Docker run will create a container from my Nginx image. Okay.
So using the same command, we can create containers of others as well.
Yes. For example, Docker run, I'll do Redis, the one we pulled right now, right?
Yeah.
That we pulled the image, I'll run it. See? Started running, it's ready to accept connections. Can you see over here?
Yeah.
It's as simple as that. You just throw a run command, it'll bring the latest image and it'll run it. Here it did not download the image because I already had the image. Okay. I'll show you that as well. Wait. Just let me know whenever my terminal is not visible, okay? Or I need to clear it. I'll just simply clear it. Docker images. When I see I have this 2 Redis images, right? I have 3 Redis images, okay. What do I not have? Okay. In your machine, maybe you can try. Do one thing, Docker RMI, and first, you have stopped it, right? Yeah. Just try removing this image. So for this, you can just use the image ID, Command C, Command V, and remove it. So see, it untagged it first and then deleted it. Now when I do Docker image, I won't have the bullseye version because I deleted the bullseye version of the Redis, right? So now you can see there is no bullseye version of the Redis present over here. So that is how we can use the RMI part. Okay.
Thank you.
1 minute. Docker run and I'll show you. If the container is running, you cannot delete the image. Docker images, Docker RMI. I want to remove this Nginx image. Okay. Nginx image is this one. Yes. What does it? Okay. It's not this one. We'll be using another one. Here this one. There are 2 images I had. 1 minute. Docker RMI. See, it says error response from daemon conflict. Unable to delete the image. Why? Image is being used by the running container. Can you see the error? Image used by the running container, right? So whenever a container is running from that image, you cannot delete that image. First, you need to stop that container, remove it, and then only you can remove the image. Okay. So were you all able to do it?
How to detach the image? Detach the.
For detaching, you have to use this thing, -d. In your run command, use -d. Like this. Docker run -d Nginx. So then it will you run the detach.
After running in detached mode, I said attached. Again, it's attached.
Attach.
After attaching it, how to detach?
Then you cannot detach it. Then you have to do
Oh,
a
okay.
control C itself. You'll control C and delete, like stop the process, stop the container, and you'll have to run it again. Yeah.
And after running this Nginx, it's starting some worker process and not started. What is that worker process? Like,
It's basically whatever Nginx application must be using, right? For example, in the Redis image, it showed that it's open to start a connection, right? In similar way, Nginx is open to for like whatever web app you must be running. You can do that, correct? So it's basically the process that okay, whenever you run an application on the like if you're deploying a web application or anything like that, you see certain logs, right? After that, you are able to connect to that. Uh, right now, I just wanted you all to explore this basic command. We'll actually have a particular application running and we'll do all these things with that application as well. Okay, in a quick while. Just a few advanced commands I want to show, and then we'll do the whole running of the application. Right now, we did not see any output. Okay, what is happening in that Nginx now? I just saw that Nginx started, right? Redis started. It was open to take connections. Now we'll be doing something wherein we'll show the end-to-end scenario itself. Okay, see, when this started, now you can hit the URL and see, okay, there is a hello world or whatever application we'll be using, right? So I just want to confirm first.
it is not the library. It is not the library that is running, right? For image, there are many libraries. So whenever we start the image, the libraries are not running. So that is not worker process. It is the application is the worker process.
Yes,
Okay.
yes. Before going forward to the advanced commands, can I get a hands up or a thumbs up if we are done with all these commands? Did you play around with all these commands? Okay, I'm getting thumbs up. I got 7, 8. Okay, I think we all are there together. Okay, I'll quickly again share my screen. Yes. So after this demo time, let's see some advanced commands. So for example, now what I want to do is I want to start.
Kinnari, sorry. Do you think we can take a break now?
Let's take a break after this one. Like I just want to show a quick 1, 2 advanced commands and then we can take a break. Okay.
Sure. And we have a hands up as well.
Okay. I think hands up was for that only. To tell
okay.
you that okay, they are done. Okay. Yeah. So coming to the advanced run commands, so say for example, I'm using a Ubuntu container. Okay, I'm running a Ubuntu container and I want to interact with. I want to do some operations inside the container. How do I go inside the container is like I'll go into docker run -i-t. -i is for interactive, -t is for terminal. So this will open an interactive terminal for my Ubuntu. So I'll show you something quickly. Say docker run Ubuntu. Okay, I'm not able to see the command. 1 minute. Yeah, docker run Ubuntu. Now, when you see docker ps, you can not see my container. What happened was docker and Ubuntu happened and the container was expired as well. When you see in the docker ps-a, you see Ubuntu got started 17 seconds ago. It exited as well on this because nothing was happening there, you know. But now, if I run -i-t, you can write it like this as well. Ubuntu. And I want to go inside the shell. Bash. Bin bash. See, can you see the change of prompt? Here it was MacBook Pro, and now I am inside the root @ the container ID. Okay. So you can see that I'm inside the container now. Okay. If I do ls, I get this, all the whatever files are there inside this. I'm inside the root directory. I can even cat the etc host file. So this is basically I'm inside the container, right? It opened an interactive terminal for me. Now if I want to exit, I'll just type exit and now I'm back to my own prompt, correct? So now when I see docker ps-a, you see the Ubuntu container lasted for a couple of seconds, like 30 seconds. We done some operations over here, right? So that took 30 seconds and that way, once it was done and I exited, the container was exited, right?
So what does -i and -t means in these options?
interactive terminal.
Okay.
Okay. Now if I run docker run ubuntu sleep. So now what you can do, one more thing is docker run ubuntu. You can give any commands over here as well. So I say I'll sleep the container for 20 seconds. Okay. So what happens is this is docker run ubuntu. This will run the ubuntu and the command that is provided is sleep 20. So it will sleep for 20 seconds. So I have run it. See, it's running. My prompt is not going anywhere. Can you see that? The prompt is stuck here. That means that the container is running. Now, after 20 seconds, it will get detached. Let's see. Okay. 20 seconds take so much time. Just a minute. Yeah, see, you saw that? After 20 seconds, it was exited. And when you see over here, docker ps-a, you see it started at 28 seconds and then exited 7 seconds ago. That means it's 20 seconds, it was asleep, right? Because we gave a command. That is what happens in the Ubuntu sleep. So this is how I can execute command. There is one more pattern to execute command is docker exec ubuntu cat etc host. So what this will do is it will simply execute the command cat etc host. So now what I did was, you saw me, right? I went inside the container, I did a cat etc host and I got this information of the container, right? Similar thing I can do from outside as well. I'll do docker exec ubuntu cat etc host. Sorry, I have to, the container must be running. Okay. So what I can do is I can make the container sleep for a longer time, say 30 seconds. Okay. And do a -d so that it will detach my terminal. -d. Okay. Now the container is running. Now when I do exec, okay. 1 minute. Why is it not doing? Yes. Okay. It's not doing it because it's in the sleep state right now. Okay, I'll show you in the later stage of the demo. We saw this docker run -d nginx, that is detach mode. Again, we can attach it. But if after attaching it, you cannot detach it, you'll have to terminate the container and then start it again. Okay. Coming to the volumes part. This is a good part. Okay. In the volumes, now for example, let's run the docker in the interactive terminal. Okay. Docker and Ubuntu in the interactive terminal. Okay. Now what I'll do is I will echo a file. Let's go inside the temp directory. Do a echo. I docker in a day. Okay. I'll put this in a file, say demo.txt. Okay. I did this echo. Okay. Now when I cat demo.txt, you can see hi docker in a day is displayed, right? When I will exit the container, okay. Now again, when I'll run it, you will see, let's go inside, wait, cat/temp/demo. There's nothing there itself. Why this happened? Because there was no volume attached to this, right? As soon as the container exited from the container stopped. Since the container stopped, whatever file I had created, it vanished, right? Now, if I want this file to be persist over there, I don't want it to vanish. What I'll do is I'll mount a directory of my machine into the Docker. So what I'm doing over here is I'll give a -v. -v is for the volume. So when you see over here, exit, I terminated the container. Let's go to the run command. I've given an interactive and I'll give a -v /users Kinnari Sutaria. Okay. And do I have anything called this demo? I have demo data. So I'll map demo data with this. And I want to map what file? I want to map the temp directory of the Ubuntu container that I have. Okay. I'll run it. Now this is mounted. Now what I'll do is I'll create a file inside this. Echo, hi, this is Kinnari here. Okay. I'll put it inside the temp demo text.txt. Okay. When I do cat /m demo txt, you can see hi, this Kinnari here is there. I will exit the container. Okay, I'm exiting. Last time when we exited the container, this was not there, right? When we again logged in the container, we saw that the demo text that we had given vanished. But now when I'll run it again, I'm attaching this volume again with this. Okay, I'm keeping it attached. So when I run it, now I'll see cat /m/demo. You can see this is there. So this is how volumes work. If I want certain amount of data to be there in the container, even when I'm doing the start and stop and everything, so then what I do is I attach an external volume to the container. Okay. And this is how we can persist whatever data we want. Then we have the Docker inspect container name. What I do is Docker. Okay, this is running, right? This container is running. What I'll do is I'll take another terminal. I'll take another terminal. I'll do Docker inspect Ubuntu. See, it gives me inspect Ubuntu, gives me all the details. What ID it is, what is the repository tag, what is the host name, okay? What is the command that was executed, that was bin sh, went inside the bash. What is the SHA of the image? What are the volumes? What is the entry point? What is the host name, domain? All these things, okay? So all these things are displayed when you do the inspect container, okay? Then we have the logs.
Can you please ping that command for setting that volume?
Sorry?
Can you please ping the command for that volume, mounting that volume?
I don't understand.
You have mounted the
He
volume.
wants that command, Kinnari. You use that for mounting volume. Yeah, command.
Yeah, I can give it to you. 1 minute. Can I put it on chat?
Not this one, that volume one.
Oh, this is the volume one only. This is the volume one only. I'm not able to go to Zoom chat.
Okay, V uses. Okay, my -V. Okay, thank you.
V and whatever folder you want to mount. Okay.
Okay, thank you.
I come back to the command. I did hide floating meeting controls and not able to get the meeting controls now. Options. Okay.
Escape key will help you to pop them back.
No, it's not happening. Escape is not doing that.
Hey Kinnari, I have one doubt. So in that volume you have volume, you have attached the volume, right? Second time when you gave the command, again you have given the same command docker and -v and then attached it again, and then you showed us like it is present, the txt file is present. So once you give it, and then second time when you give without -v and -t ubuntu /
then it won't have it. Then it won't have it.
So
see, what you're doing basically is you're attaching your, for example, so consider this. I'm giving this a very brief example. It's not completely related, but it's an analogy. Okay. So say, for example, I have a pen drive. Okay. And my machine, my Mac does not have any memory at all. Okay. Whenever I attach that pen drive, I create some folder, I add the data. Okay. Now I'm removing that pen drive. That is my container. My machine is died. Okay. Now my container is dead. So when I again wake up the Mac, suppose say my Mac went to shut down. Now when I start the Mac, the pen drive is not attached. Will I get that data? No. Again, I have to attach that pen drive. When I'll attach that pen drive, I'll get the data. You're getting my point. So that is how these volumes work.
Okay, then so this is okay. Like one txt file is okay. Like if we have multiple like hundreds of txt files, then every time we have to give, for example, now uses Kinnari Sutaria, inside that you have that demo txt. If I have another user / my name Kavya, then I have another demo 1.txt. I have to give all the time when I want to go to demo 1.txt. I'll not remember, right? The demo 100 is present in which volume?
You will say, for example, in Kinnari Sutaria, there are thousands of directories, right? Okay. So I don't want to map all those thousands. What I'll do is I'll just give the upper layer, right? The users Kinnari Sutaria. Whatever is there inside Kinnari Sutaria, all will be mapped inside this. Correct?
Okay.
This is understand this is not mounting your computer's memory into the Docker. You want Docker thing into your computer.
Okay.
Vice versa, right?
Okay.
So whatever Docker is having, that I want over here. Correct. So to persist that data, I'm using this external volumes. Because see, when the container will die, everything is dead. Nothing will remain, right? If nothing is remaining, I cannot get that data. So in order to persist that data, we use the volumes.
Okay. Got it. Thanks.
We did the logs and now we have an assignment for you. So while we take a break, it will be like a quick 5 minutes for the break. And the other time you'll have to complete the assignment. Okay. It's not like an assignment, it's a small exercise. Okay. Just I'll do a slide so you don't see the answer. Yeah. So now what you have to do is in the similar way that we did all these commands, I want you to run Jenkins. Okay. Now this is a very practical example because we have used Jenkins in our day-to-day lives, right? We have used Jenkins a lot, correct? For different purposes. So now what I want you to do is go to the Docker Hub, check for Jenkins. When you check for Jenkins, you'll get a command for pulling the Jenkins file, Jenkins image. Run that Jenkins image and I want you to see it on your local. Okay, I want you to run Jenkins on your local by using the Jenkins Docker image. Is the problem statement clear? Hello? Hello?
Yes.
Can we get a thumbs up? Yeah.
Yes. Yes.
Okay, awesome. Can you make me stop share, Ishwarya, because I'm not able to get the controls.
Yes, I can.
Can you please do that? Okay, people start thinking about the problem until we resolve this small issue. Thank God, finally. Yes. So everyone, can we get a thumbs up? I don't know if you all did a thumbs up or not. But if yes, or you can put a comment in the comment section, you can put yes, so that I can understand if you've got the problem statement. And it's 11:31 right now. At 11:40, I'll start with asking if you are done or not. Okay, take 5 minutes to freshen up and 5 minutes to think about it. It's a very quick, small command that you have to use for running the Jenkins image on your local. There's a little twist. We'll talk about that twist and let's see if you all can figure it out or not. Okay, it's a small exercise.
So we can take a break.
Yeah, you can take a break. I'll pause the video. Okay, awesome. Was anyone able to run the Jenkins on their local?
Yes.
Yes. Were you able to hit the URL in the local machine? Hello?
Kinnari, your voice is a little bit low than it was.
Okay. Hello. Am I audible now?
Yes, now it's good.
Okay, awesome. Were you folks able to run the hit the URL of Jenkins on your Chrome browser? Anyone?
Yes.
Okay, who was that? I am not able to.
I'm Mohammed.
Okay, hey Mohammed. Awesome. So you were able to do it. So what did you do, Mohammed? Could you please tell me?
I just ran a command docker pull Jenkins. Then I port forwarded.
Great. That was the tweak there. You had to do the port forwarding in order to run it on your local, right?
Yeah.
That's great, Mohammed.
But I faced one issue that like first 2 times I have tried 3 times. So first 2 times the password, like when I tried, it says that authentication failed. Every time I ran, I get a new window. I mean, new password.
That's strange actually. I have never faced something like that. Okay, let's do along and see. Okay. It should not happen that way, but if you ran the container again and again, maybe that may be the issue. Okay. Because before doing the port like when you did the port forwarding and if you ran it multiple times, it must be looking for your earlier password. But if you refresh it and do it again, it must be accepting the latest one. Let's see. Anyone else faced any issue or were you able to do it? Okay. I take that as a yes from everyone. I'll still do it here for those who are having still those who are having still doubt. Okay. So basically what we'll do is I'll do a Docker run. Okay. First, let's see if there is anything in my PS. No, there is just Ubuntu container running. So that is okay. Now I'll do is Docker run. When I do Jenkins /Jenkins, so this will bring the Jenkins image from the hub and will run the Jenkins. Okay. But the problem here will be, okay, now it is running and Jenkins by default exposes its 8080 port. So I have to send my request on the 8080 port, but it won't be able to access it. Why? Because it is exposed its 8080 port, but what port it is connecting to our machine. If I want to access it over here in my browser, how will I be able to do it? Okay. That is where the port forwarding comes into picture. Okay. Say, for example, here the solution is I'll do the port forwarding. That is FNP 8081 8080. Okay. So let's do it. I'll do the port forwarding first. -P. Whatever port I want to expose, I can expose. I'm exposing 8081 over here. Colon 8080 space. When I run it, you can see it's running. It did not fetch it because I already had Jenkins in my machine. I had the Jenkins image already. This is the password for the installation. As I exposed port 8081, what I'll be doing is I'll be hitting the port 88 localhost 8081. Okay. As you can see, it's coming up. I'll refresh it. You can see. Did you all get the screen? Can you please give a thumbs up if you get the screen? Okay, I got 1 thumbs up, 2, 3, everyone. Okay, awesome. So you reached till the screen. Now when I enter the password here, I'll go and continue. I don't want to save it. Now I'll do the install suggested plugins. Okay. So now what it's doing is it's installing these plugins. Now one trick catch over here is that once my container will stop, whatever jobs I have created, whatever plugins were installed, all will go. Okay. And I start the container again it'll take me the first getting started screen and then again the whole process will start, right? But I don't want to do this each and every time. I want whatever jobs I've created to be persist in that particular container whenever I spin up the Jenkins container, right? You're agreeing, right? Whenever you want to run this Jenkins again and again, I won't go and create 3-4 jobs that I was running each and every time. It won't make sense. I want that data to be persisting over here. So what I'll do is, just give me a minute. What I'll do is, I will attach a volume to it. So you see what I'm doing is I'm mapping a certain port. You can put 8080, you can put 8081, whatever port it's free, you can put it over there. Then I'll do the mapping. Okay, I'm mapping a volume. Say user Kinnari Sutaria demo data. I'm mapping this folder with a var Jenkins _home. So there are different folders. Okay, in Ubuntu we had /temp folder. You can use different folders as well. You can create some directory over there and then mount it over here. In Jenkins, by default, all the settings of the Jenkins, whatever jobs we are creating, will be there in the where Jenkins _home. So I'm mapping this folder with my local machine folder. Okay. So now whenever I'll spin up the data, no matter how many times the container is stopped, whenever I'll spin up the data, whatever data I want will be there. Okay. I won't have to go again with the whole installation process, again setting up the jobs and all. So you understand what is the use case for this? The mounting. First is the port forwarding in order to access your Jenkins on your local machine. Okay. After that, it is the mounting of the volume. Why? Because whatever jobs, whatever users I'm creating on the Jenkins, I want them to persist. And that is why we create a volume. Am I clear? Everyone?
Can you repeat the second? What was the solution? I missed a little bit.
Okay.
Part 2.
Yes, I'll show you. 1 minute. See, this is installing plugins. What I did was I put the admin password that was provided in the terminal, right?
Yeah,
Whatever
yeah, I was, yeah.
we added that terminal password, right? After that, there was an option to install the plugins, correct? I installed the plugins. After this will get installed, no, let's see what happens. Okay. After this will install, we'll get a screen. Well, it will ask for creating a user. I'll create some user, secondary or admin or anything. Okay. I created that user and I have put the credentials for it as well. In the next screen, what is Jenkins used for? We create jobs, right, on Jenkins for running our pipelines or running our test cases, right? We create jobs. So say I've created certain jobs. One is for QA environment, one is for dev environment, one is for another something. There are 3 to 4 jobs I'm creating. Right now, everything is there in place. The moment I will stop my container, everything will be gone, right? You agree, right? Because there was no volume attached. Everything will be gone. Again, when I'll spin up the container, I'll have to start from scratch again. Go to the plugin, install the plugin. You can see how much time it's taking to install the plugins, right? Again, create a user, again, create those jobs. Then it is not simplifying my job, right? Whatever I want to do, it's not simplifying my task. So to simplify it, what I'll do is I'll attach a volume to this while I'm running. So if I attach a volume as given in this solution, what will happen is in this volume, whatever users I create, whatever users, whatever jobs I create, all that data is stored in the var Jenkins home. In this folder, inside that container, all this is stored. Okay. So what will happen is whatever data is created over here, all that will be mounted in my folder that is users Kinnari Sutaria demo data. Correct? So this will give me a edge that whenever now I'm spinning up the container again, I won't be having to do all the process, all of it again. Instead, because this container is mounted with this particular volume, I'll directly log into my log into my Jenkins and simply run the job. Okay. So the installation part, the creation of user part, the creation of job part, that'll be just one-time process. And then later you'll just have to spin up the container and start using it, right? But if I don't mount the volume, the where Jenkins home will always be empty, correct? If it will be empty, I'll have to make everything from scratch, create the user, install the plugins, create the jobs and everything. So that is why mounting the volume is important, right? Is everything clear?
Yes,
How
it's
will
clear.
get the
Thank you.
password?
Passwords every time will change. The admin user. See, this was the first time login credential, right? Whatever we got over here, this was the first time we created this, right? This is for initial setup only, this password. After the screen, after this installation, it will give a screen wherein you'll be asked to create a user. Okay. With that user, every time you'll be logging in. So that
Okay.
username, that credentials will be stored under the war Jenkins home folder. And that war Jenkins home folder is mapped with my local folder, right? So whenever I'm spinning up the container again with that volume, it will have that thing in the war Jenkins file. Since it will have in the war Jenkins file, Jenkins home file, I'll simply able to log in. Correct? Is it clear?
Yes.
Okay.
And
Awesome.
the port by default was not accessible on the browser. What was that? Why it was not accessible? Can you
I'll
please
show
repeat
you.
that part?
Yes, sure. See, now say for example, I'm not having this part itself. I'm running it. So what Jenkins, see, every application has a different set of ports that it will expose, correct? So this Jenkins by default exposes 8080 port, okay? It has exposed 8080, but how will my network connect to it, right? My laptop, not the Docker host, my laptop, how will it connect to this? In order to connect to this, I have to associate one port of mine, which will be accessing this port of the Jenkins that is exposed. It can be
Okay.
8081 as well. It can be 8085, whatever. Okay, 4026 as well. Whatever port you want, it can have over here. How I can mention the port is by -p. -d is used for detached, -it is used for interactive terminal, -v is used for volumes. Similarly, for providing the port, I use -p. Okay, so what it does is it does a port forwarding part for me.
Yeah, Jenkins is exposing 8080 only, but our ports needs to be changed.
Yes. So this will always be constant, 8080. For example, in my 8080, something else is running. So I cannot expose it to over here, right? Because one thing cannot point to two, one port cannot be pointed by two services, right? So I can use a different port, say 8081. Correct. The port should not be used by someone else. That's it. That is the only criteria for us.
Okay.
Okay.
Thank you.
Welcome. Anyone else? Anything? Any questions? This will take a little time. What you can do is you can take it as a self-practice.
And for this next command, this volume one, so that we can use after this setup ready, right?
Huh? Sorry?
I am talking about the volume command, this one. This we can use once setup is ready for Jenkins, right? Is
No,
that or when to use this one?
no. See, I just gave this to make you
Yeah.
understand why volume is required. But when you are spinning up your Jenkins, always use this second command only directly. So the port forwarding is also done. The volume is also given. So you're all set to go. Correct. You're getting my
Okay, got it. So my question is, if I use the first command, then can I use second one as well, like, or no?
See,
I'm not
second one
getting.
you can use, but
Yeah.
first instance, when you did a run, okay,
Correct.
your volume was not attached. So now my installation and everything happened. See, this is the screen that comes. Create first admin user. Correct. I'll put my name, I'll put the password, I'll confirm the password, full name and email address. I'll then save and continue. Okay. Let's do it if you want. Sorry. Kinnari Sutaria. Sorry, it's the password. Give the password as whatever you want. Admin @1234. Don't give the password as so simple, but yeah, admin @1234. Okay. I'll say the name as Kinnari Sutaria. Okay. XYZ email ID. Okay. Yeah. Say thoughtworks.com. I'll save and continue. Okay. Now this is the Jenkins URL. Every time I have to hit, it gives me this. Save and finish. Start using Jenkins. Okay. When I start using Jenkins, I'll create a new item. Say my first project. What it is, it's a freestyle project. This is a simple settings I'm doing. Okay. It's nothing related to Docker. Now I'll add some description. I'll save the job. Now this job is saved in the war Jenkins home. Okay. But when I'll stop the container, this data will be gone. And I'll start the container again, one Jenkins will be empty. So again, when you hit this URL, you'll get the first step again itself. Install plugins, then create a user, and then again the jobs. So in order to have everything in place, when you should map the volume from first itself. Since you map the volume from first, everything will be stored over there. And then when you spin it up again, you'll simply use this. All this data will be there basically. Rasika is raising hand. Yes, Rasika, tell me.
Yeah, I had a doubt. Suppose we do this second command, alerting the volume as well as port forwarding, and do some work on Jenkins, then stop the container, and again we want to run the container. Then for second time, do we also need to mount the volume again, or just running the container is enough?
See, if you're not mounting the volume, the container, how will it know that this is the data that should be there in the container? Correct. I gave the example of the pen drive in our machine, right?
Yeah.
So in similar fashion, the container won't be aware on itself that, okay, this was a volume mounted earlier. You have to mount it each and every time. Understood?
Yeah. Thank you.
Welcome. Anything else? If not, we are going to go into a very, very interesting part. Yes, Anusha.
As in line with the previous question, do we forward the port each time?
Yes, similarly, right? If I don't forward it, how am I able to access it? Jenkins has exports this port. Am I exposing anything to access it? No, right? If I'm not exposing anything, and if I just do a local host here, say I'll just kill this, okay? I'll stop the container. This is stopped. I'll refresh this, reload. It's gone. Correct. How am I able to access it? Because I had exposed a port. Now that port is shut off, right? The container is not there. Now again, if I open it and I'll just run without the port, I won't be able to access it. Want to see? See. This is up now, right? Let me see this. See, not able to access it. Jenkins is exposing, but did I forward that port to my port? No, I did not. So I'm not able to access it, correct?
Yes. Thank you, Kinnari.
No worries. Okay. People, I think we cannot take any further questions. We'll continue again on it, but still the further part which I'll explain and we'll do the hands-on, that part will really clear more picture. And I don't think you'll have any doubts on this part, on the solution part 2 or part 1, anyone. Okay. Now we are on the part of creating Docker images. Very interesting part, I would say. Okay. Let's go to slideshow. Yes. My screen is visible, right?
Yes, yes.
Okay, awesome. So creating Docker images, it's a very interesting part. You saw on my Docker Hub, right? I had several images pushed. So these were all images that I created on my own. I customized my own applications and then I wanted to create an image out of it. So now whenever I want to run, say for example, this is my office laptop. If I want to run those things on my home laptop as well, I can simply take a pull of that image and run that application, correct? It's as simple as that. So if you also want to create an image, this is how we are going to do it. The tool to create an image is Dockerfile. That is the Brahmastra to create the image. Okay, Dockerfile. So now what is a Dockerfile? Docker, is there some chat? Just I doubt it creates new container every time we do a Docker run. Yes, yes. It creates a new container every time. The container name will also change. The container name won't be same. When I do a PS over here, see, Docker PS-A, you can see it stopped the container every time. See, there are 2 times I stopped the Jenkins container, right? I stopped it 2 minutes ago and I stopped it 3 seconds ago. Every time you can see the name of the container was different. It spin ups a different container, but it uses the same image. Can you see Jenkins? And whatever volume will be mounted, it will be the same. Okay. Container is different, but volume you're putting it externally, right? If I'm having that pen drive, say the volume is pen drive. If I put it on my Mac, it will give the same data. If I put it in your Mac, it will give the same data. Correct? Whoever had asked this question, who is this? Harish. If I want to already create a container. Mounting. No, every time you have to mount it and every time you spin up a container, you have to mount and port forward. It's just a simple command. See, now the Docker file, how it will help you is, it will do all this on your behalf. Now, right now, what you have to do is you have to type that whole long command, right? -p, -v, give your folder, give the mounting folder, everything, right? But this Docker file, it will help you eliminate all those things. It will do all those things in the form of instructions in the Docker file itself. Okay. Let's see it. And still, if you don't get the answer, we'll discuss it in the Q&A part. Okay. We just have 30 minutes and I want everyone to at least push their image. Okay. You all have the Docker Hub account, right? Do you have the Docker Hub account? If not, just go to the Docker Hub URL. If you want, I can just paste the URL. Docker Hub. I had opened it. Yeah. I'll paste the URL for Docker Hub. Go ahead and just sign up. Okay. So that you can push your own image you can push your very first own image. See, I have so many images here. Similarly, you can also have your image in the Docker Hub. Okay. Yes. Coming back to the slides. Go to Docker Hub, sign up. It's a very simple process. Okay. Don't forget to remember the credentials because you'll have to use those credentials while pushing it. Okay. So what is a Docker file? Docker can build images automatically by reading the instructions from a Docker file. Okay. And the Docker file should be created like this only. The D should be capital and rest is like this Docker file. That's it. No extension, nothing. It's created like this only. A Docker file is a text document that contains all the commands a user could call on the command line to assemble an image, right? Everything in the Docker file on the left is the instruction and on the right is the argument. Instruction will be in caps. That is why I've put instruction in the caps and the arguments will be in the small letters. Okay. This is a sample Docker file. Okay. Can you see? All the instructions on the left from work dir, copy, run, copy, expose, cmd, all these are written in the caps. And these are the arguments. Node, user src app, package start or JSON, npm install, dot, that is for copying the current directory to that current directory in the container, expose 8080. So 8080 will be the argument, that's the port that you want to expose. CMD as in the command you want to run. What command you want to run? The argument is the npm start. You're getting my point? This is how a Docker file is created. Don't worry, we'll create a Docker file as well and we'll show what is happening. Okay. This is a sample Docker file. How does it look? Okay. So how to build an image? I'll put this link. 1 minute. I'll put this link on the chat. I want you all to clone this repository. Okay. Yes, I've added it on chat. Could you please clone this repository? In the meanwhile, I'll okay. First, just shoot this command. Okay, shoot this whole command itself. That'll be great. Git clone and the repository link. Shoot this command on your terminal, and whatever text editor you are comfortable with, open this repository over there. So, for example, I have it on the IntelliJ. I'm using IntelliJ. Okay. Okay. Just click on it. It must look something like this. And you have to go inside the app folder, pd app folder. Here you can see I have the Docker file, package JSON. Okay. So second src. Were you able to clone it? Can you please put a thumbs up or any reaction? Are you able to clone the repository that I gave? Folks, you have to clone this repository because we are going to create an image out of this repository. So until you don't clone it, you won't be able to do the hands-on part.
I see a few thumbs up.
Okay, okay. Awesome. So now to build an image, this is the command docker build -t getting started. 1 minute. I put a flash. This is the ideal way. Okay. Docker build. Build is the command that we use to build the image. -t as in tag. You saw, right? When I was in the Docker hub, you saw that we had the tag folder, right? There's a tag. So what happens is the Docker image should have a tag like this. Kinnari Sutaria is my personal hub account. Can you see Kinnari Sutaria over here? So this is the syntax to write it. Kinnari Sutaria. And then whatever image name I want to give. Okay. We call it as a repository name. So this repository name should be the name you want your image to have. Okay. It should be in small only. Okay. So this is the tag that my image will have. And the dot resembles, the dot resembles that in the current directory, whatever Docker file is there, build that. So for example, in this app folder, there's a Docker file that I have. So when I run Docker build command over here, I want it to use this Docker file. Okay. When I give a dot, it'll use that file. If your Docker file is somewhere else, you can give a -f and give the path to that file. But ideally, wherever your app is, in that root itself, you have the Docker file. Okay. Is it clear until here? Okay, you're not able to clone this, is it? Srilekha.
Yeah.
While cloning?
Yeah.
Okay. Strange.
It says not able to clone into read-only directory. Should I create a new directory in main?
Yeah. That's regarding Git permissions. You have to check wherever you have a permission, or maybe you do sudo if you are not able to clone it. But Git clone should work ideally. Yeah.
Instead, I can download this repository and then.
Yeah, you can do anything. This is the simplest way. You just have to have the repository in your machine. That's it. You can clone it, you can download it, whatever you feel like. Okay. Can you share the build command? Yes, I can share the build command, but before that, you'll have to add the Docker file as well. I haven't added the Docker file in the repository. Okay. I'll paste the command over here, but this will be your name, your hub account name. Okay. And whatever you want to name the app. Docker build -t, your hub account name, and the getting started in dot. Before that, you'll have to add the Docker file. Now let me explain the Docker file. Okay. So is this font proper? The font is proper, right, for the Docker file?
Yes, this is better.
Okay, great. So basically, this is my app folder. In this app folder, I have to have the Docker file. Okay. What this Docker file will do is, this is a node application. Okay. Since it's a node application, my base image is of node. Okay. Node Alpine is the most stable one. You can use any one which you want. I'm using the node 12 Alpine image. Okay. Now run. What we'll do is, once this image is got, these are the layers. Okay. These are the layers of the image. The first layer is getting the node. That is the base image. From node, we are creating this particular image. Then I want this image to download the Python. Okay. So it will add the Python APK. After that, it will create a working directory name as /app. Okay. Now it will create copy all the things that are there in my app into this app folder. Okay. As you can see, we have a spec folder, we have a SRC folder. It doesn't concern what is there inside that. We just have simple application code itself. Okay. We have the package.json. Okay. It has a simple application code only. We want to see it in the UI. That is why I'm showing it here like this. Okay. So then what it'll do is, after copying, it'll run yarn install. Okay. It's giving -hyphen production. We can have a dev, staging, whatever environment you want. Okay. You have to have it yarn install -hyphen production. Now command. CMD is, as soon as all this is done, okay, all this above part is done, what it'll do is, it'll do a node src index.js. Okay, it'll run this command and it'll expose the port 3000. By default, this node image always exposes 3000, like Jenkins exposed 8080, right? In the same way, node will expose 3000. Now coming back here, before executing the build command, let's understand.
Sorry, Kinnari, like I need to create a new file called Docker in the apps directory.
Yes, yes. It should be given as this name. Capital D
caps
and small. Yes. Okay, that's the ideal syntax for creating a Docker file. Okay. Let me explain again. I almost explained the whole part. The Docker build command uses the Docker file to build a new container image. You might have noticed that Docker downloaded a lot of layers. This is because you instructed the builder. So when I'll run this build command, no, it'll see different layers, as I explained, right? First it'll take the node, it'll add the Python, it'll then run certain commands, right? Then after Docker downloaded the image, the instructions for the Docker file copied in your application will be installed. Okay, whatever yarn install you have to do and whatever Python installation you have to do, all these things will happen. Then it'll run finally the CMD command over here and it'll expose the port 3000. -t is added for the tag. As I explained earlier, right? To have a human readable name for the final image, you can add a tag. The dot again at the end is to pick up the Docker file that is there in that particular folder. Okay. Okay. Is there any questions until now? Yes, I can share the Docker file. Just give me a minute. I'll share it. Where is the chat? Here. I've shared the Docker file on the chat. Give me a thumbs up when you have copy pasted the file. Did we get the thumbs up, Anusha?
No, not yet.
Okay. Are you folks able to copy paste it?
I see 2 thumbs, 3 now. Okay, a few more.
Okay, great.
Yes.
Put the Docker run command too. The name, you can put any image name. Okay. Your name and the repo name. This is how we'll run it. First, let's build it. I sent the build command above, right? Yes, I've sent it. So you are inside, make sure you are inside the app folder. Can you see? I'm inside the app folder. Getting started, app folder, right? Now I'll first do a Docker build. Docker build -t. -t is the tag. I want to have it as Kinnari Sutaria / Docker in a day demo. Okay. And dot. Don't forget to put the dot. It will check the current app directory for the Docker file. Build. See, it's building. Okay. It's putting the layers. Can you see? All the layers are done. It's installing the yarn. See, copy directory, working directory app. It ran the APK. Can you see 2 of 5, 3 of 5, 4 of 5, 5 of 5. 5 of 5 is the yarn install. It's running it. It'll take a couple of minutes. Are you all along with me?
Can you please scroll up a little bit on the terminal?
Yes, definitely.
Here -t, that command you have put, right? Docker build -t, and then Kinnari Sutaria /. So this name should be, or what is this location about?
Kinnari Sutaria is the hub account name. In my Docker hub, I have this name. My account name is Kinnari Sutaria. And this is Docker in a day demo is whatever whatever repository name you want. Okay. So when you go over here in my hub account, your Docker hub, yeah. Can you see? Kinnari Sutaria /compose demo, Kinnari Sutaria /test infra. These are different images. Okay. So image name can be anything, but this should be your hub account name only. That is the standard way. You can find your hub account name over here in the right corner in the profile section. Okay.
Yeah.
Is that fine?
Yes, thank you.
Yes. Can you see the images created? Now where I can see the image, I can see the image.
Actually, I'm getting this error. Not sure.
Okay, what is the error?
I have pasted it in the chat.
Let me take a look. Docker build -d. What is the error?
Yeah. No, above that. Above that.
I cannot see. I did not get the ping.
Sorry.
Yes, Hari, it's not there.
Just a minute. Just a minute.
Open wireless Docker.
For me, it is saying unable to find the image when I run the command in app.
Yeah, I have shared it.
You do not have to run the image for when did you run the image? Did you run it
No,
down?
not run. While building the image itself, it is giving the error. I have pasted it.
The Docker file open wireless Docker. Okay. It's not able to find it. Did you write the Docker file as I said?
Yeah, I have just copy pasted that.
Yeah.
Okay. Wait. Let me try.
For checking the Docker daemon is running or not, do column status. When you do column status, you'll get if the Docker
It is working. It is working.
Right? And if it's not running, no, column is not running, it's in a stop state, no, just do a column stop and column start again. It will start. The column status should be in the running state. Okay. So now my image is created. What was my image name? Docker in a day demo. The tag is latest because I did not give any tag. Okay. This is the image ID and it was created 17 seconds ago and the size is 430 MB. Okay. Now to push it, I just have to do Docker push. Even before, okay, let's run it first and then we'll do a push. Okay. Chat. What was the issue? Okay. So
while running it, actually, industry page is not found like that.
Okay, can we first complete the running and then we can check the error because we are running out of time, right? I just have to cover one more small topic after that. So, Docker. Okay, I pasted the command, right? This. So just do Docker run. By default, what port you're exposing? This is 3000, right? So just expose 3000. What is the image name? Copy the whole proper image name. Otherwise, it won't run. Okay. 3000, Docker demo. Okay. So it's listening on port 3000. Can I go to the port 3000 on the local host? Yes, I can go there. Go to the Docker 3000. As you can see, localhost 3000 is showing me the to-do app. You can see the to-do app. This is the to-do app that we were running. So simply it is coming up. Are you able to get it? Is it coming up for you? Are you able to run the image? I can see.
Can we get a thumbs up? Oops.
Okay. Can you put a thumbs up here so that we'll understand if you're able to pin up the container from the image? Because you did not go inside the app. Go inside the app directory and then trigger this, create the image and then trigger the run command. No. Go inside the app directory, CD app, because you're in the getting started folder. Go inside CD app and then do the trigger. Then run the build command. The image will be built and then run the Docker run command.
Actually, I'm inside the app folder, though I'm getting the same similar error. Cannot find the module app source.
Is it?
Yep. So I have added the Docker file inside the app folder, and I ran the build command from there itself. So the image is created. And now when I'm trying to run the command from the run the container from the app folder itself, it is giving that error.
Were you able to run containers earlier?
Yeah.
Okay. Okay, let's see those errors in the later stage. Okay.
Okay.
Let's first complete it because Docker Compose is also remaining. Okay. So basically when you do this, simply the UI will come up. My application is up and running now. Okay. But now what I want is that, say this was a standalone application. Okay. It was not running multiple containers and all, right? So, okay. Before that, we have the one small thing. Yes, here. So difference between CMD and entry point. So here, no, when you saw this is a CMD, right? And here we can have the entry point as well. It will be written like this. Entry point. Okay. So what is the difference between the entry point and the CMD? Both are there to run the command itself. Okay. So a very simple example is, say, for example, in my Docker file, I wanted to have an Ubuntu image and wanted to sleep for 5 seconds. Okay. So this is the command I pass. Create a Docker, or like take a Ubuntu base image and sleep. When you run the container, it should sleep for 5 seconds. Okay. So what I did was basically, and this is the Docker file format. Now, if I put a command, it will be like this, right? Docker run Ubuntu. This is the container name that I'm giving. And this is the sleep 10. It should sleep for 10 seconds, right? So now the CMD, whatever was there in this file, it will be replaced by this. It will become sleep 10, the whole thing. Sleep file will be replaced by sleep 10. But say if someone else, I know this, that I have to give an argument after running the container. Okay. But if someone else doesn't know it, okay, say if Anusha is running it, she doesn't know that she has to provide a the input over here, right? So what will happen? Sorry. I replaced it. Go to the, this is right. This will be completely replaced by sleep 10. Sleep file will be replaced by sleep 10. Now coming to the next Docker file, we're using entry point. Okay. Entry point as in, this is the sleep command that should be executed, and the argument for the sleep will be given in the while running. So Docker run my image name and the argument over here. Now everybody won't know, right, that they have to give an argument. So what should happen is, like when I'm giving the argument, the sleep will be appended by 10. Okay. So here it is replaced. The sleep 5 is completely replaced by sleep 10. And here the sleep will be appended by 10. Here I'm not giving the sleep command explicitly because it doesn't look good, right? Docker run Ubuntu sleeper, sleep 10. By the name itself, I'll come to know that, okay, Ubuntu sleeper means it will be sleeping my container for a certain time, right? The sleep doesn't look good. That is why I put the entry point. But I have to pass a 10. I did not know that. So if I put it empty, it will throw me an error, right? Because the sleep command did not get any argument. So that's why for the entry point, you should give a command as well in the last. So if it gets the argument from the command line, that is 10, then well and good. If it doesn't get, it will simply take the by default argument as 5. Okay. This is the difference between sleep and the command and the entry point. Any questions on this?
Entry point is like it accepts the argument.
Yes, yes. It accepts the argument from the command line. Appending will be happen. So after sleep, 10 will be appended. Okay. But here in the command sleep 5, the sleep 10 whole thing will be appended. But it doesn't look good, right? Sleep 10. So Docker run Ubuntu sleeper, sleep 10. Of course, this Ubuntu sleeper, as in the name itself suggests that it's going to sleep for 10 seconds. So why to give the command explicitly over here? That is why what we do is we put it in the entry point. So entry point will just mention the command and what argument should be given. We can give it from the command line, or if we missed giving it from the command line, it will take the by default from the CMD.
So what if we want to give two arguments from the run command and all?
Sorry?
2 arguments. Now we're giving just 1 argument, right? Like let's say if you want to give 2 arguments, like 10, 15 or something, any 2 arguments, how it will happen?
Yeah, you can give any number of arguments. Say for example, okay, cat etc horse also has 2 arguments only. You can give any number of arguments here. Okay, we can just separate it by comma. So for example, in the CMD I have 5, no? I can separate it by comma, whatever arguments I want. You understanding?
Okay.
And that is yeah. Got it. Now there's a main part, that is Docker Compose. So right now I was doing all this on my own, right? I created a Docker file, okay, for creating the image. Now from that image, I had to create the container and run it, correct? So what if I wanted to create 4 or 5 containers? Every time I had to do Docker run Redis, Docker run Nginx, Docker run MongoDB, Docker run Ubuntu, right? So there are a lot of run commands going on. Even if I have multiple Docker files created, I'll have to run those. It is a tedious task, right? So that is where Compose comes into picture. So what Docker Compose does is, Compose is a tool for defining and running multi-container Docker applications. Okay, when there are multiple containers, Compose is the tool that we should use. With Compose, you can use YAML file to configure your application services. Okay, there's a YAML file used, which will configure all the services that you want in single go. With a single command, you create and start all the services from your configuration. Okay, Compose works with all environments, production, staging, development, testing, as well as CI workflows. It also has commands for managing the whole life cycle of your application. I see a lot of chats going on. I'll address them later stage. First, let me complete the Compose part. Okay, we'll come in the Q&A and we'll resolve your issues. Okay, whole life cycle. Okay, it can help you start, stop, rebuild services, view the status of running services, stream the log output of running services. Okay, all these things Compose can help you with. Now you can use Compose. Using Compose has 3 steps. One is define your app's environment with a Docker file. Okay, so it can be reproduced anywhere. Define the services that make your app up in Docker Compose YAML. Okay, so you have to have a Docker file, you have to have a Docker Compose.yaml file. This is the syntax for the Docker Compose YAML file. Okay, Docker-compose.yaml. This is the way you will define it. So they can be run together in an isolated environment. Now you run Docker Compose up. This is the command, Docker Compose up, or you can use Docker-compose up. Okay, this will start your container and run the entire app. Okay, now let's do the Docker Compose demo. Okay, coming over here again. So this is my Docker file. Okay, I created a Docker image as well. I'll just again check what my Docker image name was. Images. Yes. So my Docker image name was this Docker in a day demo, right? So going to the Compose YAML file, I'll paste the Compose YAML as well in the chat. Please add it. I pasted the Docker Compose YAML file. Okay. So first it starts with the version. Okay. This is the 3 version. Services. What services you want to spin up? So I want to spin up an app. What is made out of an image. So what image? I have created an image, right? So that image should be, it should be used. Now, right now this image is on my local, okay? But still, When it will be on the Docker Hub, it will simply take it from there. So then I don't have to have the image in my local as well. So whatever the space the image is taking, it'll also be gone. Whenever I want the container to run, it'll take the image from the at that time itself. So in the meantime, you don't have to keep the image stored over here. Okay. The tag is latest because I did not give any tag. Okay. The host name is app, container name, whatever container name you want to give. I've given docker.com demo, restart always okay. And then ports. What ports I want to get exposed. So in this Docker file, you said you are exposing 3000. Okay. But in the Docker compose file, we'll say, okay, for this 3000 port that is exposed for my app, I wanted to map it to my 3000 container. We did a port forwarding, right? In the Docker run command, you must have seen. You saw the Docker run command, right? In the Docker run command, we port map whatever the folder was, the port was, right? 3000, 3000. This is a different command. So yeah. So that port mapping is done in the compose file itself. Now what I'll do is, I'm in the app directory. Okay, let's see what are the containers running first. And Docker PS. Okay, this is running already, Docker in a day demo, and it has the port forward 3000, 3000. So what I'll do is I'll first remove it. RM. Okay. Okay, we have to stop it first. We'll stop it first. Okay, now I can do the RM. It is removed. Now when I do Docker PS, you see, we don't have the container that was running earlier saying Docker in a day demo. Okay. Now what I'll do is I'll simply do Docker compose up. See what it's doing? It's creating the container and now its container is created. I'll simply go back. I'll do a Docker PS on the other command, one moment. Other terminal. When you see Docker PS, you see there's a container running with the image Docker in a day demo latest, right? It has done the port forwarding as well. I'll go in my to-do app and I'll refresh it. See? Are you all with me?
Can we get a thumbs up, folks?
Yeah.
Can you go back to the compose file, please?
Yes.
Yeah. So here, like it will anyways refer to the Docker file, is it?
No, it won't. It will refer to this image that is there on my latest. Say, I'll show you something.
Okay. So anyways, we need to create the image first and then.
Yes. Image should be there. If you want to build it, like if you want to not have the image and then have it, so there's a set of arguments wherein you can give a like here instead of app you can give a parameter name as build. There's a different set of arguments. I'll give that. You can find the documentation in the Docker Hub itself, Docker docs. This is the simplest version you can use where you have the image ready. Okay.
Okay, so this is just to
don't have the image
simplify
ready,
the run process.
Yes.
Yeah,
if you want to build part also done over your building of the image part, that also can happen. It has a little different syntax. Okay. So this I did was, I'll just stop this container. Okay. Docker PS. It stopped. Okay. When I refresh, it's gone. Correct. Now what I wanted to show is a simple thing. Say, sorry. Say my application needs Redis as well. Okay. I came to know it after a certain time. My dev will come and tell me, okay, infra consultant, I want a Redis as well. So what I have to simply do is add your image. I'll simply use the Redis image. You have to be very aware about the syntax over here because the syntax and the YAMLs are very important. It'll give you an error if there is one space missing, like you can see over here. Since the space was missing, it won't take it, right? You have to keep it like this only. So now I added Redis over here. Simply, you see, I'll just simply do Docker compose up. When I do Docker compose up, it'll take the, can you see Docker com demo created? The Docker com demo created. That is the Docker com demo, that container that I wanted. It is created. After that, it'll go ahead and create the Redis. Okay. Redis was there on my local machine. So what it did was it went, it saw the Redis, it checked, it initiated the server, and then it started. Now when I see Docker PS here, I see 2 containers running. Can you see? Docker inner day and the Redis. In the data set, someone comes and tell me I want MongoDB as well. I add MongoDB as well over here. You're understanding? This is how, when I want multiple containers running, each and every time I don't have to go to the container, run the Docker demo container, run the Redis container, run the MongoDB container. No, by the Docker Compose, it will help me spin up multiple containers just by one command, that is Docker Compose up, right? Is that clear?
Yeah, one small thing. Can you go back there in the compose file? So the Redis that we have written on the line number 10, does it play any role, or it should be the same, like it is syntax?
No, this should be the same syntax. It
Okay.
cannot be different. Yeah. So all this, no, you will get it in the documentation as well. Okay, how we have to put the YAML file. If you want to have a build, what you should do. If you want to add volume as well, how we should do. All these things will be there in the Docker docs file itself. I'll send the link at the end. You can refer that for adding different. This is the most basic thing I've shown. In the real time, when you go and see, there are big Docker Compose files. Okay, which will have so many details, all the security things and whatnot, different ports, because in some applications we'll be having multiple ports mappings, we'll be having different DBs using different things. So all these things should be there in the compose.yaml, but for now, this is the very basic version that you should be having. Okay.
Is it possible to kill all the instances at a go? Like since we started.
Yes. Say up now, we have, let's see. We can kill all the instances and we can remove all the images as well. I have 3 containers, right? Running. I can stop them all. Docker RM, which will remove. Just put the first 3 letters, or one more option is give the variable here. So here Docker PS. If I do a Docker PS, all the stop containers will be removed, right? If I do -a, all the stop containers will be removed, because now it's no such containers, because there's no containers which are in stop state. Okay. Are there anyone in the stop state? 1 minute. Or basically, if you want to remove multiple containers at a go, you can do this as well. Docker, first stop them. 26A, give the starting IDs itself. That's it. Starting 3 or 4 numbers. F800. Okay. This will stop. Then I can simply remove it. RM $Docker PS. It's running. Okay. Okay. You can say this way also you can use it. It's not taking it right now because it's running some containers. Okay. But right now, like this, remove and just put the starting container ID. See, when I did a remove, the other 2 containers were gone. Do you see?
Okay.
Okay. Now coming back. Someone said something. Yeah. So this demo, okay. Were you able to do Docker Compose up? People who are getting errors, we can resolve them post this thing. Okay, we are 9 minutes above. Just one last thing I need to cover, and then we can wait for doubts and others can drop off. Okay. The networking part. So in the Docker network, yes, the Docker takes care of the networking aspect so that the containers can communicate with each other and also with the Docker host. Okay. Docker's networking subsystem is pluggable using drivers. Several drivers exist by default and provide core network functionalities. There are 3 main types of networks: bridge, host, and the none. Okay, where everything is isolated. When you talk about the bridge, this is the default network driver. So when you go and see over here, Docker inspect. Okay, we stopped the container. No, we won't be able to see it now. But when I see network ls, it will show me all the networks. Can you see? Bridge, host, right? The name of the container is bridge, host, none, right? So in this way, we have different networks. Okay, the bridge is by default. So whatever containers we created right now were all on the bridge network because it's the default network. If you don't specify a driver, this is the type of network you are creating. Okay. Bridge networks are usually used when the application runs in a standalone containers that need to communicate. On my Docker host, whatever containers I'm creating, it will use bridge network to communicate with each other. Okay. Say, for example, one container was Node, one container was Redis. So it will use a bridge network in order to communicate with each other. Now for host. Now for host network, the standalone containers remove network isolation between the container and the Docker host. So now there will be no network created. Whatever my Docker host is using, that network only will be used by my containers that I'm creating. Okay. Now, user-defined bridge networks are best when you need multiple containers to communicate on the same Docker host. When you have one Docker host and you have multiple containers running on them, bridge network is the best because it will help you communicate with each other in the Docker. Host networks are the best when the network stack should not be isolated from the Docker host, but you want other aspects of the container to be isolated. Okay. When you are not concerned with the isolation of the containers, you can use the host network. Okay. And in the none, for this container, disable all networking. It cannot have any communication with anywhere outside. So when you do this port forwarding, all this stuffs, that won't be happening when the network is mentioned as none. This would be for some high security application, or when you don't want it to connect with any of the network outside, then you can use the network as host. It will give you complete isolation because it will disable all the networking itself. The very simple commands over here are that in order to see what network are, what are the networks available, you can do a network ls that we did right now. When you do Docker inspect bridge, it will give you details about the bridge network that we have. Okay. When you do a Docker container inspect, whatever container is there, it gives you the major container details that we saw earlier. Yeah. Then we have Docker run -d, that is run the detached mode, -p, that is it'll run the it'll do the port forwarding. Now what I'm doing is I'm creating this network. Okay. In the next command, you can see Docker network create my network name. I'll quickly show this demo if everyone is okay with it. I'll just go back. I'll create, I'll just see what is running right now. Docker PS. Okay, we don't have any containers. Docker create. What is the name? I'll simply copy this. Testnet. So testnet is the create network. I'm creating a network. Okay. Sorry, network create. Control C. Docker network create testnet. So this is the command. Testnet is already there. Testnet 1. Okay. Now it created. Now I'll do a Docker network ls. So when you do a Docker network ls, you can see testnet 1 over here. Okay. So now testnet 1 is there, and I'll run this container itself again. Okay. Whatever is the node application, the to-do app that we have. Okay. I'll try to run this. I'll exit the full screen. I'll show you the to-do app is down right now. Okay. It's down. Now I'll do I'll run this. Docker run. I'll do Docker run. This is test. Okay. I'll remove this name. Network testnet 1. I want to name the container as network demo con. Okay. I'll finally give the image name as well. Image name is this. So when I run it, it should use my testnet 1, this thing. Testnet 1 as the network. Now when I go here in the local host, I'll run it. So as you can see, the app is up, right? Now the app is up. As you can see in the slides as well, what I said in the slide was that it is pluggable. Networking is pluggable in Docker. So that is what we'll see. We'll now unplug the network. Okay. I'll just do Docker network disconnect. I'll do a Docker network disconnect for the testnet. And my container name is network demo con. Okay, I disconnected the network. So now what do you expect over here? It should go down. It's down, right? Now again come back. I can reattach. As I said, it's pluggable, right? So now I'll do just network connect instead of disconnect in the same command. When you go back, I'll just make this connect. Then when you did a connect, now I can go back, go to the to-do app, and then you see the app is up. So this is how the networking works in the containers. Okay, it's really pluggable and very flexible. Anytime you can remove it, anytime you can modify it, everything. Okay, finally, yes, I'm sorry to take 15 minutes extra, but yes, now we are done with the session. I hope you all did a lot of hands-on along with me. Okay, if you have any doubts, I'm here for helping you out. And for others, if you want to drop off today, we are done with the demo. Okay, we're done with today's workshop, and I hope it helped you in understanding Docker, the overview gist of it, and also doing a hands-on of at least creating an image and all. Yeah, just one last thing I forgot was 1 minute. Just this one last thing. Now, since I created the image, right? I just want to do a Docker push. I'll show you how to do it. Docker push. Simply Docker push and put the image name. Okay. What's happening? You do a Docker push and your image name. That's it. It's as simple as that. It starts referring to the repository. It's preparing. You can see it'll take time because it's 400 MB image. Okay, it'll do all this, and when it's completing, the download is complete. Upload is completed. You can simply find it here in the repositories part. 1 minute. Yeah, you can find it here in the repositories list. This, I just pushed this compose demo image, which is of the same application itself, 14 hours back. Similarly, if this is done, once this is done, it will simply upload it over here and you can find it here. That's it. For pushing the image, it's as simple as just a command that is Docker push your image name. That's it. Yes. So finally we are done. And I'll stop sharing. Yes. Go ahead with your questions. I think we can stop the recording now.
Sure.
Thank you.